This is a tutorial for the Atterberg Limits Lab of the Geotechnical Engineering course CIVE 3208. The purpose of this lab is to determine the plastic limit, liquid limit, and plasticity index of a soil sample. Soil can exist in a solid state, a plastic state, or a liquid state, depending on its water content. The plastic limit corresponds to the water content at which the soil changes from solid to plastic. Similarly, the liquid limit corresponds to the water content at which the soil changes from plastic to liquid. It is important to know these limits as they help us predict the way the soil will behave. For these tests, you will need approximately 200 grams of material passing sieve number 40. To measure out a sample, take an empty container, like this bowl, place it on the scale, and zero the scale. Then measure out approximately 200 grams of soil. Now add water to your sample. Do this gradually while mixing. You will want to create a uniform paste of soil that sticks together. If your sample is too dry, add more water. If your sample is too wet, keep stirring it. Never add dry soil to your sample, as that will cause it to clump together and therefore affect the results. To measure the liquid limit of soil, you will use this device known as a Casagrande cup. Once your soil sample is prepared, you can fill the brass cup. Take a part of your soil and fill the cup like this. Use a spreading tool to squeeze and flatten the surface of the soil in the cup so that it's horizontal. You will need enough soil so that the sample is about 1 centimeter thick at its deepest point. Use a grooving tool to cut a groove through the center of the brass cup like this. Make sure that the brass cup is clearly visible through the groove. Now that the Casagrande cup is set up, we can start the test. Turning this handle will cause the cup to rise to a height of about 1 centimeter and then drop to the base. Start turning the handle continuously, counting the number of drops. As the sample drops, the two halves of the sample will approach and eventually meet each other. Stop the test once the contact length between the two halves of the sample is greater than 13 millimeters. Ideally, the number of drops will be between 25 and 35. If this is the case, then the test was successful. Record the number of drops in a table. Now determine the moisture content of the sample. To do this, take a moisture container and identify it with a number. Then record the mass of the empty container. Place a small amount of the sample in the container and record its mass. Place the sample in an oven for 24 hours to dry. If your number of drops was not between 25 and 35, you will need to redo this test. In both cases, put the sample back into the storage container. If your number of drops was less than 25, your sample is too wet. You will need to mix your sample, allowing water to evaporate, then repeat the test. If your number of drops was more than 35, your sample is too dry. You will need to add water to your sample, mix the sample, and repeat the test. Repeat this process until you get between 25 and 35 drops. You will need to repeat the test successfully 2 more times to get 3 data points in all. For the second and third tests, increase the water content by adding water to your sample and mixing. This will reduce the number of drops. You will want the number of drops from at least one of your tests to be less than 25. This is because the liquid limit corresponds to this number of drops. In order to accurately determine the liquid limit, we need at least 1 data point less than and 1 data point greater than 25 drops. When repeating the test, you will find it easier replacing the sample back into the container by removing the cup. To do this, loosen the screws, push the pin back, and lift the cup out. Remember that you are recording the number of drops it takes for the two halves of the sample to meet each other for a distance of 13 millimeters. For each of your 3 successful tests, record the number of a moisture container, its mass, and the mass of a sample of wet soil placed into it. Place all 3 samples in an oven to dry. It is okay to do the test more than 3 times. After at least 24 hours, remove all your samples from the oven. Place the containers of dry soil on the scale and record the mass of each corresponding to the number of the container in your table. Using the data recorded, calculate the moisture content of each test. As was mentioned before, each successful test corresponds to 1 data value that will help us determine the liquid limit. The data will be plotted on a graph like this. The y-axis is the moisture content. It is on a linear scale and will have a range large enough to contain your lowest and highest moisture contents. The x-axis is the number of drops. It is on a logarithmic scale. Plot all your data points like this. Now find the line of best fit. The liquid limit is the moisture content corresponding to the point of 25 drops along this line. To determine the plastic limit of the sample, we will need a flat surface such as this glass pane. Take a small lump of the sample like this and roll it into an ellipsoidal shape. Place this on the flat surface and start rolling it back and forth like this. The objective here is to continue rolling the sample until it thins to a diameter of 3 millimeters. If your sample sticks to the flat surface as it is doing here, this means that your sample is too wet. You will need to place the sample back into the container, mix the soil to remove some of the moisture, and try again. Once you have created a strand 3 millimeters thick, you can use the steel rod as a guide to know when to stop. Check closely for cracking. If there is no cracking, your sample is too wet. This is what cracking should look like at a strand diameter of 3 millimeters. If cracking occurs before you reach a thickness of 3 millimeters, your sample is too dry. Place the sample back into the container, add water, mix the sample, and try again. Once you've done this, determine the moisture content of this sample. Place a numbered moisture container on the scale and record its mass in a table. Record the number of the container you are using. Place the sample in the container and record the mass of the container plus the wet soil. Then place the container into an oven to dry. After 24 hours in the oven, remove the sample and record the mass of the now dry soil plus the container. Calculate the mass of dry soil. Calculate the mass of water. Finally, calculate the moisture content. The plastic limit is equal to this moisture content. The plasticity index is equal to the liquid limit minus the plastic limit. Calculate the plasticity index. Now that we have the liquid limit, plastic limit, and plasticity index, we have completed the Atterberg limits lab.